Joins in SQL. Joins, and Cartesian products, are realized by using two or more relations in the from clause of a select statement. The presence of more than one tables in the from clause imply that the selection will be done on the Cartesian product of these tables. By applying a carefully crafted condition on the product, we may get a join operation. This does not mean that the database management system will actually compute the Cartesian product. Usually, database management systems avoid this costly operation, and use various optimizations to find the result, without computing the whole product. However, the final results are the same as if the product was computed and used. The condition in the where clause is the selection operation. The attributes in the target list imply the projection operation. All of these operations can be combined to perform a join operation. For example, to get the names of employees, and the buildings they work in, we must join the employee and the department tables, as the table for employees has no information on the building, and this information can only be found by using the relationship of the employees to their departments. The query to find this information is: select first name, last name, building. From employee, department. Where employee.department equals department.department ID. Please note that we have to state explicitly the condition to be used for the join operation. In the previous example, we do not tell the database management system that the query is actually a join, an equi-join in that case. Instead, we just use the select statement, and its implied operations, to get the result of a join. Alternatively, we can use a slightly different syntax, to explicitly state that the query is a join. In this case the query becomes: select first name, last name, building. From employee join department, on employee.department equals department.department ID. In this case, we tell the database management system that the from clause does not imply a Cartesian product but a join on a condition. Please note that the query does not have a where clause, since it is not needed anymore. Instead, it states the condition of the join, in the from clause, using the on keyword. Another variant that can be used for natural joins could be: select first name, last name, building. From employee natural join department. However, this will not work in our database, because it requires that there are attributes with the same name in both tables. In our case, the attributes for the department ID have different names. This would work, though, if the table employee used department ID, instead of just department, for the relevant attribute name. Then, the names of the attributes would be the same, and there would be a natural join of the tables. Similar to the explicit join variant, there are outer join, left outer join or left join, and right outer join or right join variants. Ordering the results. SQL allows us to order the results, using the order by clause, in the select statement. The order by keyword is followed by a list of attributes, each optionally having an ascending or descending designation. The results are ordered by the first attribute in the list. If there are any tuples that have the same order, then they are ordered according to the second attribute in the list, and so on. For example, the query: select first name, last name, salary. From employee. Order by last name ascending, first name ascending. Will order the results alphabetically, based on the last name, and for those having the same last name, also based on the first name. Similarly, the query: select first name, last name, salary. From employee. Order by salary descending. Will order the employees, from those with a high salary to those with a low salary. Aggregate operators and groups. Apart from the expressions in the target list, we can also have expressions that calculate values based on groups of tuples, such as sum, average, minimum, maximum, and count. Each of these functions is followed by the attribute, on which it operates, in parentheses. Count can be used to count the number of tuples, and the number of appearances of specific attribute values. For example, using the star in the argument of count, counts the number of all tuples in the result of the query. Using a specific attribute in the argument of count, counts the number of non-null values in this attribute, Counting the duplicate ones, while using the keyword distinct before the attribute name, counts only the number of non-duplicate values. The other aggregate operators can have as arguments an attribute, or an expression, but not the star. They operate on attributes that make sense to operate too. Sum and average operate on numeric types, and time intervals. Maximum and minimum operate on attribute for which ordering is defined, such as numeric types, strings, time intervals, etc. For example, to get the mean of the monthly salary for all employees, we use the query select average of salary divided by 12 as mean monthly salary from employee. Similarly, to get the annual salary cost of Department 7, we use the query select sum of salary from employee where department equals 7. Please note that these aggregate operators ignore null values in the attribute they operate to. Aggregation functions can be applied to partitions of the tuples of a relation. In order to specify the partition of tuples, we use the group by clause, followed by a list of attributes. The tuples of the result of the query form groups having the same values in the attributes appearing in the list of group by. Then the aggregate operators are applied to these groups. The final result contains one tuple for each group, having the attributes of the group by clause, and the result of applying the aggregation function to the group. For example, to get the average salary by position, we can use the query select position, average of salary from employee group by position. Please note that the target list must make sense for the query, i.e., it must contain only the attributes used in the group by clause and aggregate operators. Finally, it is possible to filter groups out of the final result by using specific selection conditions. These conditions are included in the having clause. Essentially they are like the conditions in the where clause, but they are conditions on the aggregate results. Clearly, the selection of groups differs from the selection of the tuples. The condition on the where clause is used to select the tuples that will form the intermediate result prior to forming the groups. The condition on the having clause is used to filter the groups, and include in the final result only the tuples for the groups satisfying the condition. The having clause must appear after the group by clause, as it makes no sense otherwise. For example, to get the average salary for positions that average at more than 12,000 we can use the query select position, average of salary from employee group by position having average of salary greater than 12,000. Summarizing all possible clauses, the syntax of the select statement is select list of attributes or expressions from list of tables, where conditions on tuples, group by list of grouping attributes, having conditions on aggregates, order by list of ordering attributes. The select and from clauses are obligatory. All other clauses are optional. Nested queries. The where clause of a select statement may also use the results of another select statement to form the selection conditions. In that case we have a nested query. The condition in the where clause can be a comparison, such as equality, inequality, etc., with a result of another query. In that case the result of the nested query must correspond to a single value. If the result is not known to be a single value, we can use other operators to test for possible inclusion of the comparison value in the results of the nested query. Such operators are in, not in, and exists. The in operator is true if the value of the attribute specified is included in one tuple of the result of the nested query. The not in operator is true if the value of the attribute specified is not to be found in any tuple of the result of the nested query. Finally, the exists operator is true if the nested query has one or more tuples, i.e., if the result of the query exists. For example, to find the employees working in the department that resides in a specific building, we can use a query in the department table to find the department ID for each such department, and then use the in operator to test for the existence of the employee's department in the result of the nested query. The query, thus, becomes select first name, last name from employee, where department in, select department ID from department. where building equals N1. Please note that there are other queries that can be used to get the same result. For example, we could use a join to get the same result. In general, there are many ways to pose an SQL query to the database management system. Usually, the query used is a matter of personal preference.